Cumulative Review 3, number 18, finding the solutions. Now, you can graph this in Desmos. The catch is, if you graph this original equation, the only answer it would give you is the actual solution. It would not give you any extraneous solutions if you needed to look for them. So what we like to do is take it out of radical form and get it set into quadratic form, and then just check those two answers. All right, so to do that, how do we undo a radical? We square both sides. That's what we were doing right here. When we did that, x squared just becomes x squared, and the square here just cancels the square root, leaving you with the expression underneath of it. And once you get to this point, you don't have to rearrange it and set it equal to 0. You just graph it the way that it's written in Desmos. Graph it in Desmos the way that it's written. And you'll see where it crosses through the x-axis. It crosses through at -2 and 6. Just plug each answer back into the original equation to see which one works and which one does not. The one that does not work is known as the extraneous solution. You can see here that -2 did not work out. It turned out, when we plugged it in, it was like -2 equals +2, which is not true. This one worked out and came out to be 6 equals 6. So that one is the solution. 19, finding the vertex. Honestly, you can simply type that in the Desmos, graph it. Vertex is the starting point of the graph. The other thing you could do to skip that is just know what your h and k values are, keeping in mind that h is the opposite of the sign that you see. I see -5, which tells me that h is a +5. K is the number that comes after the radical, and it is what the sign says, -7. Number 20, domain, how far left and how far right. Just graph this into Desmos, and you can see that the graph is going to go as far left as -4, and it goes forever to the right, so it goes all the way to positive infinity. The fact that it reaches and touches the -4 is the reason why I put a bracket there. All right, if it had like an open circle there, then we would put a parentheses. Number 21. All right. Trying to determine if a table is direct variation or inverse. Here I gave you the original direct and inverse variation equations. However, when you're trying to determine if a table is direct or inverse, you're trying to find the constant. In other words, you're trying to solve for k. So if you notice what I did here, when I solve the direct variation equation for k, it comes out to be this equation, meaning you want to do y divided by x. If I do that, y divided by x, I get 10. Here, I get 10. Here, I get 10. Here, I get 10. I got a constant answer of 10 every single time. And so since that worked out, that lets me know it's direct variation. For inverse variation, if I solve that equation for k, we get this, meaning x times y. If I multiply x times y and I get the same constant answer every single time, then I know it's inverse. This comes out to be 20. Multiply this, we get 20. Multiply this, we get 20. So the constant is 20, and that is inverse variation. If neither one of those worked out, then that lets you know that it's neither direct or inverse. 22. First thing I notice is the word inversely, varies inversely. So that tells me this is an inverse variation equation. Now I got to go back and figure out what is varying. The hours varies inversely with the number of workers. So I take this and I want to set it up to use letters that make sense to the problem. Hours and workers. Okay. How many hours the first time? 10. How many workers? 4. So I plug that in. I solve for k. I got to multiply, right, because it says division. And I get k equals 40. I want to rework the problem with the 40 and the new numbers. How long would it take 5 people? So I come back over here, I rework that same equation, plug in my 40 for k, 5 for the workers, and 40 divided by 5 is 8.